Hello, my name is Ardi and we are going to solve this problem here, E5.6. So the question is use Thevenin theorem to find V0 in this circuit here. Where is V0? V0 is this one here, which is the voltage across this 4 kilo ohm resistor. So we need to take off this 4 kilo ohm resistor from the circuit and we need to analyze the rest, right? Let's take this off from the circuit and we will need to do Thevenin theorem. Okay, and we are asked to use Thevenin theorem. We need to do 3 steps. The first one will be finding the Thevenin resistance here, or RTH, and the second one is to find out the Thevenin voltage, which is VTH, and then the number 3 is draw VTH and RTH, and then we need to find V0, right? So we'll have N find I0. I mean V0. Okay, find V0. Good. Okay, now let's do the first step, which is find the Thevenin resistance. Okay, let's do that. Find RTH. Okay, we need to take off this 4 kilo ohm resistor, so we already take it off. And then we also need to replace the sources. We have voltage source here and also a voltage source. We need to replace voltage source with short circuit. So we have short circuit. And if we have current source, we need to replace it with open circuit. Okay, so what we need to do is redraw the circuit to find the RTH. Okay, we replace this 6-volt voltage source by short circuit, so we will have only cables in this branch, and we still have that 6 kilo ohm resistor. So we'll have 6 kilo ohm resistor, and then we will have this 3 kilo ohm resistor. Okay, we'll have 3 kilo ohm. Good. And then what else that we can get from here? We have this 2 kilo ohm resistor. So we have that 2 kilo ohm resistor. And remember, we are taking off this 4 kilo ohm resistor because we are looking for this V0. So we replace this branch here by open circuit. And so we need to find out the RTH loop from this point here, which is RTH here. Okay, and how to find the RTH? Let's see. RTH, or the Thevenin voltage, I mean Thevenin resistance, is equal to this 2 kilo ohm, which is in series with 3 parallel with 6. 3 parallel with 6. Okay, let's change that 3 parallel with 6 to mathematical notation. So we have 2 plus 3 times 6 divided by 3 plus 6. Okay, so I'll have 2 plus, this one will be 18. This one will be 18. And then divided by 3 plus 6 will be 9. So we'll have 2 plus 2. And 2 plus 2 will equal to 4. So RTH is 4. And the unit here will be in kilo ohm because all of our resistors here is in kilo ohm. So we'll have 4 kilo ohm here. So our RTH is 4 kilo ohm. Okay, and I think that's all for number 1, 4 kilo ohm. Let's move on to the second one, which is to find the Thevenin voltage. Okay, let's clean up the board first. Okay, the second thing that we need to do is to find out the Thevenin voltage. So we have to do it, find VTH, okay, and that is the open circuit voltage, right? Open circuit voltage. Okay, let's redraw the circuit. We need to take this 4 kilo ohm off, so we will have this 6-volt voltage source, and then that will be 6 kilo ohm. And then we also have this 3 kilo ohm. And then we also have this 12-volt voltage source, but with the flip sign here. And remember that we replace this 4 kilo ohm by open circuit because we are looking the Thevenin equivalent at that point. So we'll have it like this. Oh yeah, we have this 2 kilo ohm resistor here. But then we are looking for the open circuit voltage here, VTH, right? Because there is no current that goes here, the voltage here will also the same as the voltage here. So this one is also VTH, right? So we don't need this 2 kilo ohm resistor. So we replace it with short circuit like this. Good. And now what can we do from here? Let's set this bottommost node here as our ground. So the voltage here will be equal to 0. But then this node here is equal to minus 12 because that is minus 12 volt from the ground. And this part here is 6 volt from the ground. And let's assume the direction of the current. This is going to the right and this is going down. Okay, what can we do is we do KCL at VTH. So we'll have KCL at VTH. What does KCL say? KCL says that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, the only current that goes in is this one, and that current is 6 minus VTH divided by the resistance between them, which is 6. And then that will equal to this current here, which is VTH minus 12, and then divided by 3. Good, multiply both sides here by 6. And on the left hand side, we'll have 6 minus VTH. And then on the right hand side, 3 and 6 will cancel into 2, so we will have 2 VTH. And then minus and minus will become plus, and then 12 times 2 is 24, so we'll have plus 24. Okay, let's do some mathematics here. 6 minus 24, that will be minus 18 on the left hand side, and then 3 VTH on the right hand side. Divide both sides by 3, and so we'll have VTH here is equal to minus 6, and the unit here will be in volt. So our VTH here is equal to minus 6 volt. Good. And now we need to do the last step here, which is the third step, draw VTH and RTH and find V0. Okay, let's do exactly that. Okay, the last step that we need to do is to draw VTH and RTH as Thevenin equivalent circuit and then finding V0. Okay, remember that we have this 4 kilo ohm RTH and minus 6 volt VTH. So that is drawn in series. So we'll have plus and minus here, and the value will be minus 6 volt. Okay, and then we have this Thevenin resistance, which is this 4 kilo ohm, right? So this is our VTH, and then this one is our RTH. And then we put this 4 kilo ohm back to the circuit. So we'll have this one here as 4 kilo ohm. And then what are we looking for? The voltage across this 4 kilo ohm resistor. So we'll have V0 here. And I think we can use voltage divider to find out V0 here. V0 is just this resistor here, 4, divided by 4 plus 4. This resistor and this resistor multiplied by the voltage source here, which is minus 6. Good. Now we'll have P0 is equal to 4 divided by 8 multiplied by minus 6. This will cancel into 1 and 2. Then 1/2 multiplied by minus 6 is minus 3. So I'll have P0 is equal to minus 3 volt. And that is how to find P0 using Thevenin's theorem. Okay, this is our conclusion. Hopefully I did not make any mistakes in my calculation. And I think I did not, because that is the answer given by the book. Hopefully I can help you understand this question. See you in the next video. Bye bye.